Hello, this is Mrs. Vaughn. I want to talk about some more vocabulary words for circles. We're going to talk about what tangents are and what secants are and the angles that they make when they intersect. Okay, tangents and secants are lines that intersect a circle. The tangent line intersects a circle at exactly one point. Here's a circle with the line, and they only intersect at that one point. That point is called the point of tangency. Okay, secant line is a line that would intersect the circle at 2 points. Okay, it's a line that goes through the circle. A special characteristic of the tangent line is that when you have the radius drawn to the point of tangency, that's the point where the tangent line touches the circle, it's perpendicular to the tangent line. So the radius is perpendicular to the tangent line. Angles are formed by tangents and secants, and there are 4 scenarios. You can either have 2 tangent lines that intersect outside the circle. You can have 1 tangent and 1 secant. Here's a tangent and a secant line that intersect outside the circle and form an angle. 2 secants, they both go completely through the circle, intersect outside the circle. And then 2 secants where actually these are chords, but they're part of a secant where they intersect inside the circle. So you notice we have 3 angles that have vertices outside the circle and 1 that has the vertex of the angle inside the circle. The first 3 are going to have the same formula because whenever you have an angle with its vertex outside the circle, you use this one formula, and then this is going to be a separate formula. So let's take a look at those. In all of our scenarios, it's going to be really important to notice where the angle is and what the intercepted arcs are on the interior of that angle. So this tangent, this is when you have 2 tangent lines. And so it only touches the circle at one point, and so it's only divided into 2 arcs. The whole circle is divided into 2 arcs, a big one and a small one. So we have our angle, our big arc, and our small arc. Okay, so our formula, every time we have a vertex outside of the circle, is going to be the angle is equal to half of the difference between the big arc and the small arc. So we always put the big arc first because we want it to be a positive number right here. So the angle is equal to half of the big arc minus the small arc. In this next scenario, we have a tangent that intersects the circle at 1 point and a secant that intersects it at 2. And so we look in the interior of this angle and we see what the intercepted arcs are. So this is going to be the big arc right here, the yellow, and then the green is highlighting the small arc. So it goes from the point where it intersects a circle, where it's going to divide the circle up, and we're going to, let me put a point right here. And so we look at the interior of the circle for our arcs. All right, so we have the angle is on the outside of the circle, so we're going to use this formula, and we take half of the difference between the big arc and the small arc. When we have 2 secants that intersect outside the circle, again, they intersect outside the circle, and our formula is the same. Angle is equal to half the big arc minus the small arc. Looking here where our angle intersects the circle and where the intercepted arcs are, we have our big arc is only from here to here, and our small arc is only from here to here. So that's going to be important to use because those are the numbers that we have to use in our formula. In this 4th scenario, we have 2 secants, or we have parts of secants, which are the chords, okay? And they cross inside the circle. So that means we're going to use a different formula. The only difference between this formula and the one that we had used previous is that we're going to add our arcs. We are not subtracting, we're adding. Okay, so we look for our angle. We see that it is inside the circle. So we have our angle, and we notice that it has intercepted arc. Okay, so our angle is here. And it really doesn't matter if we have the big arc in our angle or not, but so we use this when we add, it doesn't matter as much. But I'm going to use this one as my big arc. And the small arc is actually the intercepted arc of the vertical angle. So we have this is our small arc. Okay, so the two arcs are going to be its intercepted arc, the angle's intercepted arc, and then its vertical angle's intercepted arc. Great, so let's just do a recap of what we've been talking about. Okay, so a tangent line intersects a circle at exactly one point. So I'm going to draw a tangent line right here and have it intersect the circle at exactly one point. That point is called the point of tangency. When you have a tangent, draw another tangent, and the radius is drawn to the point of tangency, we know that the radius and the tangent line are going to be perpendicular. That means they make a 90-degree angle. The secant line is a line that intersects the circle in 2 points. And you can have more than one, but anyway, it's a secant if it intersects it in 2 points. When those lines form angles, we have formulas to help us figure out the measurements. So we have three types of situations when angles are formed by lines and the vertex of the angle is outside the circle. So one of them is when you have two tangents and they intersect outside the circle and they form two arcs, a big arc and a small arc. We have another situation when we have a tangent line and a secant line that form an angle with its vertex outside of the circle, and when two secants form an angle outside the circle. They also have intercepted arcs. So there's three pieces of information, but our angle is going to be equal to half of the big arc minus the small arc. Okay, so then we have the other formula when our secants go through the circle and we form an angle. Okay, and so we're always going to use the intercepted arc of that angle and of its vertical angle. Okay, but the only difference between this formula that we use right here and the one that we had before is that we're going to be adding the big arc and the small arc. So we have the angle is equal to half of the big arc plus the small arc. Okay, I'll give you some examples soon, but I hope this helped. And thanks for watching. Mrs. Vaughn.